Could an AI really make life or death decisions for an entire city during a massive public health crisis? You know, it sounds like something straight out of a sci-fi movie, but it's a question researchers are taking incredibly seriously. Okay, so picture this. A brand new virus is spreading like wildfire. Hospitals are getting overwhelmed, and you, like everyone else, are looking to your mayor for answers. But what if that mayor wasn't a person, but an AI? Could it actually handle the pressure, weigh all the data, and make those incredibly tough calls? Well, that's not just a thought experiment anymore. A team over at Virginia Tech decided to take this question out of the realm of what if and put it to the test. They built a whole virtual city and handed the keys to an AI just to see what would happen. So let's dive into how they did it. To test an AI mayor, you can't just drop it into a real city, right? You need a sandbox, a virtual world where it can make decisions and you can see the consequences play out without any real-world risk. So meet Jennifer. That's the name they gave the AI agent at the heart of this experiment. They basically told her to act like a pragmatic mayor for a city of 1 million people. Her job, for one full simulated year, was to keep the city running by balancing public health against the economy, all based on the data she was given. Now, this diagram here is really the engine of the whole experiment. Here's how it worked. Every single week, Mayor Jennifer got a data dump, the latest case numbers from her city. Based on that, she had to make a call on business restrictions, fully open, fully locked down, or somewhere in between. That decision then got plugged back into the simulation, which changed how the virus spread, which of course created new data for her to look at the next week. It's this constant cycle of action and reaction. And listen, this wasn't some simple video game world. The simulation was powered by what's called an SEIR model. That just stands for susceptible, exposed, infectious, and recovered. It's the same kind of mathematical foundation that real-world epidemiologists use to forecast diseases. So while it was a simulation, it was one grounded in some serious science. Okay, this is where it gets really interesting. The researchers didn't just test one version of Jennifer. Nope. To really see what makes a difference, they set up this kind of contest between 4 very different AI leaders. So you had 4 contenders in the ring. First, the standard agent, just your basic single AI. Then, an agent who got a little help, a cheat sheet explaining the basic rules of how epidemics work. Third, you had a committee of 10 standard AIs who all had to vote on what to do. And finally, an expert committee. That's 10 AIs that all got the cheat sheet before they cast their votes. So you've got the 4 mayors, 1 city, and a crisis that lasts a whole year. The stage is set. But what actually happened when they hit go? I gotta say, the results were definitely not what I would have guessed. Before I spoil it, just take a second. What's your gut feeling? Who do you think did the best? A single, focused AI or a whole committee bringing that wisdom of the crowd effect? You'd think more AI brains working on the problem would be better, wouldn't you? Well, get ready for the first huge twist. That committee of standard AIs, the ones without the cheat sheet, they were the worst performers, by far. They actually ended up with 1/3 more infections than the single standard agent. So yeah, just throwing more AI at the problem made things significantly worse. And these 2 graphs right here tell the whole story. Let's look at the one on the left. That shows the daily cases over the year. See that big yellow line that peaks way higher than everything else? Yeah, that's our underperforming committee. Now look to the right at the final results. The blue circles are the agents that had no special knowledge. Compare that to the red squares, the agents who got the cheat sheet. Wow, the difference is just night and day. So just how big of a difference did that cheat sheet make? It wasn't just a little better. We're talking about a massive, massive improvement. And the winner is the expert committee, the group of AIs who all had that bit of extra knowledge. They didn't just nudge the numbers down. They managed to cut the total number of infections in half compared to the single standard AI. They totally flattened the curve and, in this simulation, saved the most lives. This all leads us to the biggest question, right? We know what happened, but we have to understand why. Why did one little cheat sheet make such a gigantic difference? Was it some super complex algorithm? A massive library of data? Nope, not even close. It was just a couple of sentences, written in plain English, that explained the basic mechanics of how an epidemic works. It really just boiled down to simple, common-sense statements about cause and effect, like this one. They explicitly told the AI that its actions have direct, predictable consequences down the line. It wasn't about giving it the answers, it was about giving it a mental model of the world it was in charge of. The key concept they taught the AI was all about feedback loops. Simple stuff like more infections lead to even more infections. That's a reinforcing loop. But also, as cases go up, people tend to get more careful, which helps slow things down. That's a balancing loop. Just understanding these basic dynamics let the AI think ahead instead of just reacting to last week's numbers. And that right there is the key takeaway. This wasn't about raw computing power. A little bit of domain knowledge, a simple understanding of the system's cause and effect, that was the real game changer. Quality of information completely beat out quantity of AIs. All right, so let's wrap this up. What should you take away from this amazing experiment? 1. AI could be an absolutely incredible tool for helping us think through complex policy decisions. 2, and this is a big one, more AI is not always the answer. In fact, it can make things worse. 3, the real secret sauce is giving the AI some domain-specific knowledge. It's a huge performance booster. And that leads to the final point. The future probably isn't AI replacing human experts, but AI working with human knowledge to achieve incredible things. This whole thing was about a pandemic, but the lesson here is so much bigger. It's like a blueprint for how we could tackle other huge, messy challenges, whether it's the economy or climate change. It's not about building an AI that knows everything, but about teaching it how to think about the problem. Which really leaves us with a fascinating question, doesn't it? What's the next complex system we should teach an AI to understand?